It's available on YouTube. Okay, we are live now. Okay, students, is it fine? Yes, it's live there. Good. So let me do slideshow. Okay. Now everything is fine. I'm audible. I hope I'm audible to all of you. Okay. Yes. So students, first of all, let me tell you. Okay. So this is our first class, isn't it? So what you need to do is that you can put a text in the chat box. It will be fine for me. Okay. What you students will do now? Don't unmute yourself. Okay. If I ask from you, then only you will unmute yourself. Otherwise, what you need to do is that just text in the chat box. I'll get you, all of your views. Okay. So first of all, text me. I'm audible. Text yes or no in the chat box. Please text I'm audible. Meanwhile, I'm seeing what the YouTube students are doing. Okay. What is happening on the YouTube? Let me see from here. Yes. So text me, students. Is everything fine? I'm audible properly or not? Okay, no one is there on the YouTube live chat. No issues. Yes. So Hannah Akbar have texted yes, and Harshita have texted yes, sir. Okay, so I'm audible. That's fine. Cool. Hannah, I'm audible. Okay, cool. So now we are going to start it. Okay, students, I'm closing my video. I'm launching a technical poll for a while. Okay, please participate in that. Okay, no quizzes are available here. No issues. So we'll start. Okay, I'm audible. Slides are properly visible. I can see now from the screen itself. Okay. Yes, on the Zoom, some students have put the text in the chat box. Harshita says yes, cool. So let us start it. Fine. See, students, the main thing is this, that this slides and video, I mean this PPT slide and the audio must be clear for all of you, okay? If this is fine, then it will work. Sometimes you may see the video, sometimes you don't see the video of mine. It's not required. Whenever I will demonstrate something, then only I will tell you that please look on the video. Other than that, you can be focused on this PPTs and audio. Audio must be clear, okay? I'm telling this again. So now let us start it. See, first of all, we'll go to the contents, okay, of today's class. Basically, in some other regions, if I tell, see, before you, the class was also in like Chandigarh region and like, Bhopal region. So for the students in this Hyderabad region, these are the contents, okay? They are like, hold on. They have already completed these things, okay? And you are lagging behind, okay? Because this is our first class in this, okay? So I'm presenting this here. So this we'll study today, that is what is ray optics, okay? Okay, you want my introduction? Anybody want introduction or you want direct to start the class? Text in the chat box. Do you want the introduction or do you want me to directly start the class? I'm writing here. Do you want introduction? Text in the chat box. Introduction of mine, or you want the class to start? He said, class start kar do, please. We don't want any introduction. Just start the class. What do you say? What do you say, students? Start the class or sir, give us some introduction? Introduction means of yourself, sir. What's the name and all these things? Is it? Yes or no? Please text in the chat box. Students, please text in the chat box. So one of the students have texted. Yes, admin is there. Ahan Akbar is there. JNV, EKM, I don't know the full form. Harshita is there. So few students are there. Good. Start the class. Okay. So Harshita says start the class, sir. We don't want your introduction. No issues. Okay. By the way, my name is this. I given here. But you told start the class, so we'll start it. Okay. Fine. So what is ray optics, students? Just be focused over here. Okay. For you, basically, it's not a revision, it's contents. Okay. I mean, this is first time for you. If you see the other YouTube videos on the same channel from which you are watching on the YouTube, you'll find the previous parts. Okay. So content of today is this. What is ray optics? First, we'll study this. What we'll study, students? We'll study what is ray optics. We'll study our subject. I mean, see, this is our topic, that is ray optics. But what is this ray optics? We'll break the words and then we'll understand it. Okay. After that, we'll study some important terms which are related to which will build our foundation for understanding this chapter. Got it? Then we'll study plane mirror and how light behaves with the plane mirror, its interaction. We'll try to complete these three topics, okay, which are basically two of the some important terms, and plane mirror and light interactions is basically subtopics. Got it? Is it fine? So are you ready? Yes or no, students? Yes or no? Okay, so you are saying, sir, we are fine, please start it. Okay, so here we go. See, students, hold on. Okay, so we will be also seeing, okay, let me tell you some more parts. Some more things. See, will be after that, those three topics, if we are left with some time, we'll also study spherical mirrors. Okay. Yes. We'll also study spherical mirrors. We'll study some important terms, okay, which are related to spherical mirrors, and numericals will solve if we are left with time. Otherwise, we'll do just three things only. These three things. Okay. So here we go. First of all, students, this is on the screen. Okay, you can see this is our first topic of the contents. That is, what is ray optics? Okay, by the way, let me ask from you people, you students, do you know anything about ray optics? Anything? Anything about ray optics? Yes or no? No, nothing. Blank. Okay, let me tell you. See, optics is something, just focus on the PPTs. Okay, don't focus here and there. Optics is a branch of physics. Optics is what? It's a branch of some physics. Physics is what? It's itself from science. It's a part of science. I mean, science basically science is a vast thing. You can't like, you can say like this. But see, we study science like this, PCM, or biology also. Biological science, mathematical sciences, chemistry, and this physical sciences of physics. So it's a branch of optics is a branch of physics, and it is divided into two parts. Okay, ray optics, and according to your syllabus also, and also officially, and also JE according to JE, NEET or KCT syllabus. Okay, I mean whatever the exam you want to give, state colleges exam, and that also it is like this ray optics. The chapter rather is wave optics. Wave optics, students. Sorry, wave optics will study afterwards, not now. First, we'll start the ray optics. So this is our topic, that is ray optics. What is it? You can see on this picture, students, you can see on this picture that there is what? A bulb here. Okay. And bulb is what? It's a light source. It's a light source, light source. Light source means what? Light comes out of it. Fine. Can you differentiate man-made and natural sources from this paper? The drawing which is pasted, which is like on this PPT. Can you differentiate the light sources and like, the man-made light sources and the natural light sources? The man-made light sources and the natural light sources. Can you differentiate, students? Anyone? Anyone, students? Okay. Finish. No one. Okay. Okay, let me tell you. See, if you focus here on this cell phone, it is a man-made source. It is a man-made device, science with technology, we made it. If you own the phone, see like this, the light is coming out of this phone. No, we know this thing. It's also light kind of. It's also kind of light source. Clock, digital clock, light comes out. Computer, light comes out. Moon, natural source, natural. Headlights, man-made. Television, man-made. Lightning, natural source. Fireworks, fire is natural. Fireworks, the patakas and all these things. I mean, crackers is man-made. Lamp, man-made. Electricity is natural. I mean, so it's a fusion of these things. Firefly, purely natural. Stars, purely natural. Sun, purely natural. Flashlight, man-made. Fire, natural. Candle ka, this, everything is natural. Okay. So, but why are you telling us this man-made and natural sources of light? Or if you say overview kind of thing, why are you telling us this that this is like a light source. What's required? I mean, why it's required for understanding this topic, that is ray optics. Okay, let me tell you this thing. Okay, see, if you focus here on this slide, please don't make noise. If you focus here on this slide, that is this next slide for understanding ray optics, you can see this. This is what? Cloud. Okay, and the rays which are blocked by this, I mean, the sunlight is basically blocked by it's the cloud. This blacky clouds are creating what? These are creating obstruction in the path of this sunlight. Got it? And due to this, you can see it's a very beautiful scenery which we're able to see. The rays are coming like this. These are rays. Okay. So from here we can say a ray is something which is a kind of line in the direction of light. Okay. A ray is something which is a straight line in the direction of light. So from here, among these two words of our chapter, that is ray optics, one word is clear. That word is ray. Now we'll understand optics. Got it? See, let me tell you one thing. If any one of you among the class is feeling any doubt during the class session, you can raise your hand. You can send emojis, or you can, you can do text or cut, tick, or you can put a text in the chat box. Let me tell you how to send the emojis. Okay, go in the chat box, and then you can click on that kind of thing, smiley face. You can send emojis like, sir, I didn't understood. Sir, you can send like this, sir, I didn't understood. Okay, you can send any of the emojis. Got it? I hope you understood what I'm saying. So this was the thing. Now let us switch back. Cool. So now we understood actually what is ray. Now we'll understand what is optics. Okay. Ray kya tha waise? Revise it. Ray is something, a straight line in the direction of light. Okay. Optics is what? It says optics is a branch of physics which is concerned with light and its behavior, pattern, and properties. Okay, so basically it says optics is a branch. If I explain you in the simple words, it says optics is a branch of physics in which we study light as a ray and its behavior matters. In its behavior pattern, that how this light, when projected on say some mirrors, some matter, or this kind of thing, how it behaves, what are the phenomena it will show. Okay, so if I combine both the definition, we'll say ray optics is like this. In the ray optics chapter, or you can say like this, what is ray optics? If someone is asking from you will say, in ray optics is also known as, by the way, geometrical optics, and it's a branch of science that describes the light propagation in terms of rays. Okay, and if you want to explain them more, you can say like this, that sir or ma'am, in ray optics is a branch of physics, okay, in which we are treating light as a ray, and ray is something which is a line drawn, an arrow which shows from the source of light towards the receiver. Okay, so ray optics is a branch of physics in which we study light as a ray, a straight line in the direction of the light, source to receiver, and its interaction. Remember this is the second point, important, and its interaction with matter. Okay, what kind of matter? Say plane mirror. You will study this thing in the further slides. Okay, plane mirror or say spherical mirror, and when this light interacts with these kind of matter, these kind of things, or some parts, it will show different phenomena. What kind of phenomena it will show? What kind of phenomena it will show? It will show reflection. It will show refraction. It will show diffraction. Reflection, refraction, and diffraction. Got it? Is it fine? Yes. So now, students, ray optics definition is clear. Okay. So JNB Ernakulam have joined. So JNB Ernakulam students have texted me, sir, we have joined. Please carry on here. Okay. So very good. Ernakulam students, you are somewhat no issues. Okay. So be in the class. So for Ernakulam students, I'm telling you what I did actually is I just explained what's the definition of the topic of our chapter, that is ray optics. Got it? I just explained this. Okay. Now focus on the PPTs and the audio must be clear to you. Okay. So this ray optics definition is clear, that in ray optics we are treating the ray as what? A line drawn in this, and its interaction with matter, showing different kind of phenomena: reflection, refraction, and diffraction. Got it? Yes or no, please? Students, text me so that we can study the next thing, that is properties of light. Please, students, text me, sir, yes, no, or send emojis, or raise your hand, sir. We didn't understood or understood. You can do anything, but at least give me a response. Okay. So Arshil says yes, sir. Arnakulam says, student says yes, sir. Good. I hope all other students also understood. Okay. Let me see on the YouTube what is happening there. Hannah says yes. Good, 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 good. Now, students, just wait. Let me see what are the YouTube students doing here. Okay. What is happening on the YouTube? What is happening? Yes, one of the students, like, I think he or she haven't muted herself. Okay. Okay. Now, students will be studying this, that is properties of light. Okay. Jyoti is here. Good. So now I'll be studying properties of light. Right? What are the properties of light? Okay. Remember, student, throughout this chapter, you have to keep in your mind these four. What are these four lines? Okay, these four properties of the light. What it says, it's very simple. Okay. It's clear here. Let me mute the person. Who is this? Please unmute. Please mute yourself. Priyanka Mahakur Jinvi, please unmute yourself. Okay, so let me unmute. Maybe by mistake you have muted. Sorry, mute yourself. I mean mute yourself. So I muted everyone. Okay, now the voice will be clear. Again, you are mute. Please don't unmute. Mute yourself. Yes, cool. Fine. So remember these four properties of light, students. Focus on the PPTs again. What are the four properties of light? Anyone? These are on your screen. Okay, these are the four properties. So you have to remember throughout this chapter कि first property क्या है? कि sir speed of light is equals to c. Sir ये तो हमें पता है. Okay, if you know, it will be like a revision for you. Okay, don't worry. And next property is this: light is electromagnetic wave proposed by a scientist named as Maxwell. Remember this. It consists of varying electric field and magnetic field. So if I draw the picture, it will be like this. Suppose this wave is a light wave. Please. Who is this? Please mute yourself, or either you can leave. Leave sense in the sense ki if like some other have joined. See, if you see, if I draw this picture, this kind of wave is what? Suppose it is like, it's a wave in which electric field and this magnetic field are what? Perpendicular to each other. This is electric field, this is magnetic field, okay? And this is wave is moving like this with c speed, that is speed of light, that is 3 into 10 to the power 8 meter per second. Got it? Okay. Third point is this. It says light carries energy and momentum. Light carries energy and momentum. So if I talk about energy here, energy is equals to h mu, okay? And momentum here is equals to h by lambda. Energy equals to h mu and momentum equals to h by lambda here. Okay? So remember this, that light carries energy and momentum, and here energy is equals to h nu and momentum is equals to h by lambda. The fourth point is this, that formula for relation between speed, wavelength and time period is this, which is applicable to light also. Okay, so what the formula says, formula is like this: speed lambda frequency. Fine, the speed, this is lambda frequency, is 1 by time period. So this is the formula. Speed is equals to lambda by time period. This all four comes under the category of what? Properties of light. So just for knowledge, students, Keep these 4 properties in your mind throughout the chapter. Got it? Now let us move to the next slide. Yes. See, अब तुम सोच रहे होगे कि like you might be thinking like this कि sir, why was the requirement of this electromagnetic spectrum here? Okay, the requirement is just this much, students, कि इसमें से only we need what? This region, that is visible region. So whenever I'm talking in this chapter about light or light, talking light or radiation which falls on this region or wavelength range of the electromagnetic spectrum, okay, which is equals to 400 nanometer. So this is the range of lambda, okay, where which we are, whenever I say about the light ray, it is the light from the visible region. So like this Vigyan. Fine. Got it? Yes. Now students will see. See, if you talk about the rest of the electromagnetic spectrum, there are gamma rays having highest frequency, X-rays higher frequency, alternating less frequency, visible less, lesser. But if you go from here, it's highest, max wavelength, it's the minimum wavelength, it's the minimum frequency, it's higher maximum frequency. Okay, just for knowledge. So the notes will be given to you in the PDF format. Okay. So what you need to do, you can see these things for knowledge. Okay, it's not required. I mean, it's not so important. The main thing is this: whenever someone asks from you, you are studying about ray optics. Okay, in that we say light or light ray. Which light we are talking about? Are we talking about all this all the ranges of the wavelength? No. You will say, sir, we are talking just about a small range of wavelength which falls in which range? In the visible region. Okay, got it? Yes. Now, students, let us move towards the next slide, which is important. Okay. Now, just make the notes. We'll study some important terms. Make the notes. Okay. It starts. Also the conceptual. From here, your foundation will be built for this chapter. Okay. So you'll find like this. Yes, this is the foundation part. So now we'll study some important terms. Ray. So students, what is ray? A ray can be defined as an imaginary line drawn in the direction in which the light is traveling. Okay. Suppose this is a source of light. This is something like a source of light. Okay. So source. Okay. And a ray is what? Can be defined in an imaginary line drawn in the direction in which the light is traveling. We'll say like this. From source to the receiver. Okay. So this is how, suppose this is a source of light, bulb. So light ray I can show the light ray as this by drawing up a simple line like this, and make an arrow in the direction of the light ray. Okay. Next thing, students, beam. So what does the beam define? Beam is defined like this. That is collection of the rays. See, we have studied ray. What is ray? Ray is something in the direction of what? Ray is something in the direction of the light ray, or you can say the ray is something, a line drawn with an arrow showing the direction of the light. Okay. And beam is what? Beam the collection of such rays. Beam is what? Beam is the collection of such rays. Okay. So based on how to place the rays, if the rays are parallel, they will be called parallel beam. Okay. So based on all these things, we'll say that the beam is basically divided into 3 types. Okay. What are these 3 types? It is parallel, it is convergent, it is divergent. Here the arrows are not fine, it will be like this. Okay, let me show you the divergent more properly. So divergent beam is something like this. Suppose you are having a source of light like this. This is what? A source of light. Sir, if this is a source of light, of course light rays will be coming out. Yes, it is. So it will be like this. This is ray, arrow shows the direction of the light. See, because it is having how many rays? It's a collection of, it's having how many rays? This source, blue colored. It is having 1, 2, 3, 4. So basically we are having 4 rays here. And these are what? collection of rays. Okay, so it is among this category of, it is one of the category of this divergent. So we'll say that this is what divergent beam. This is what, students, this is divergent beam. Got it? So based on the placement of the rays, we'll say, I mean, how based on the location where how the rays like with other in connection with the other ray, whether it's making some angle or whether it's like parallel. If parallel, we'll say parallel beam. If convergent, I mean, if the rays are coming towards the point, we'll say convergent beam. If the rays going away from the point, we'll say divergent beam. Got it, students? Yes or no? Okay. So now we'll see a phenomenon shown by the light's interaction with the plane mirror, that is reflection. Okay, because see, if you've seen from the beginning slides, that is, we have studied about the definition of ray optics. What we studied? We studied in this ray optics that we'll study the light as a ray, which is basically straight line in the direction of light, and its interaction with the matter, due to which it shows different phenomena such as plane, reflection. I mean, with due to its interaction with the matter, what kind of matter? Plane mirror or spherical mirror? Okay, or and many other things. Okay, we'll study. It will show different phenomena such as reflection, refraction, and diffraction. Diffraction basically you'll see in wave optics. Got it? So that's why let us study the first phenomenon, which is shown by the light due to interaction with the matter, such as like plane mirror or concave or convex, which are the parts, which are the types of spherical mirrors. Okay. So this is what reflection. So first of all, text me, students. Did you understood everything which we studied till now? I mean, up to this slide, before this slide, are you able to understand everything or not? Please text me in the chat box. Then only I can proceed. No, otherwise it doesn't make sense. Got it? So are you comfortable with reflection? Because I will be fast now. The basic theory is completed about for this reflection. I will be fast. Got it? Yes. So one of the students have texted. Now students just focus on the reflection. What does the reflection say? Okay, you can write this definition as a notes. Okay. Okay, Rituparna cleared. Good. From JNV with JNV Panchavati. Okay, whatever. See, now if we focus on the definition here, it says what? Suppose we are having a ray of light and it's incident at a point on the surface. Here the surface is what? Surface here is plane mirror. Okay. So suppose the ray of light is incident at a point on the surface. The surface throws partly or wholly the incident energy back into the medium of incidence. Okay. So we'll say here, this is the incident ray. This is projected like this at a point. It will go like this at a point. Okay. So angle of incidence is equals to angle of reflection here. Got it? Okay. And this phenomenon is known as reflection. Okay, where this angle I equals to angle R, okay, and this G angle is known as angle of glancing. Okay, so for you, this thing can be new, that this G angle, which is known as angle of glancing. Remember this. So what is angle of glancing? If you want to explain somebody, you will say like this: the angle which the incident ray makes with the plane mirror is known as angle of glancing. Okay. And what is this angle of incidence? The incident ray with the angle which the incident ray makes with the normal. See, students, one thing you have to understand is this, that this perpendicular line is not a ray. Ray is this AO and OB. These are rays. This ON is not a ray. It's the thing which we have made perpendicular to the plane mirror. It's a geometry. It's a geometrical line, you can say. You can say it's a geometrical normal which we have made via pen paper. Okay, whatever, pencil. I mean, pencil paper on this plane mirror perpendicular to it. Okay, and this is a light we have projected from the source. Got it? Fine. Okay, good. Now we'll see the next thing. See, these are some funny images for to create an interest kind of thing. Okay, so you can see here, this is a person. Okay, this is a funny toon animative character. He's like seeing what? His image in this plane mirror. So it's due to the reflection, students, we are able to see the images. Okay, and see, this is also a person who's dancing by seeing this water somewhere in the night, maybe. Okay, so you can see the man's reflection here. Got it? Is it fine? So from here, what do you get? You get like this, see, that a person if stands in front of the mirror or the water, that there is something, coming outside from the person, that is a source of light, or maybe suppose some light source is there at the behind, and the ray strikes it and reflects it, and when it went into the water, again it gets reflected. That's why we're able to see the things. Okay. So my main mode of explaining you, giving this picture here is this: if suppose there is a source of light, or there is some other source of light, say sun. Okay, you can see now outside there is what? Sun. So the light rays are coming from the sun, they are falling on different objects, they're getting reflected from the objects, they're coming into our eyes, and there is some mechanism going inside our brain and eyes. What's that? Due to which our brain is able to interpret it. It's able to do what? Interpretation of the things outside, the information which is coded in the light rays, which enters into our eyes after the reflection from the materials. Okay, but actually, what is the source? Source is the sunlight. In the night, the source is the bulb. The light coming from the bulb reflects from different objects and enter into our eyes, and the brain does the interpretation. Got it? So what I've explained, is it fine? Yes? Good. Now students will see what is plane mirror. Okay, but before all of this, let us see very interesting animation video. Now I will show you very interesting animation video. Just hold on. Just wait. Okay. So let me show you. Just wait. I'm launching a video. Before that, you can note down this definition of the plane mirror. Okay. Okay. I will show you video just after this slide. Okay. So what is plane mirror? Suppose you take a thin transparent glass plate. This is something like a thin transparent glass plate. A transparent glass plate. Okay. And if you polish one of the side of this plate by a silver polish, something called silver polish, you will get a reflecting surface. Students, here wahi surfaces, like these are those surfaces only which we see in our day-to-day life. Okay, I mean the mirror in which you see your face. Okay, so this is like what? Plane mirror. If you'll do some more furnishing, you can use it for like optics and all these things. Okay. So students, now I'll be launching a video. Just wait.
Is laws of reflection.
See students, I'm going to show you video on your screen now. Okay, I hope it's visible to you. Is this video visible or not? Yes. Yes. So students, now I'm going to launch it. Okay, are you ready? So from this video, okay, good. So from this video, you'll understand that how this boy and this, like these are two brothers. Okay, you will see one more brother will come out. One more funny toon character will come here. Okay, so these two brothers will use the laws of reflection in a very good manner. Okay, and they will explain you that how the laws of reflection or also the reflection phenomenon by the light can be used in a very good manner such that they may get benefited in this trip. Okay, they are doing some trip. I mean, they are on the mountain and maybe they are doing some like mountaineering kind of thing. Okay, so are you ready for the video? Yes or no? Please participate. Yes or no? Are you ready for the video or not? Okay, so I'm launching it. So Akbar says yes.
Good job.
What happened to our light?
No idea.
I have an idea.
Really?
Huh?
Consider this ray of light which strikes a mirror.
Okay, so students, let me tell you one thing here. What they actually did, if you go back, if I go somewhat back, see. So, I mean, that this, his brother, he was not feeling good, this big one, okay? He was not feeling good. Now what he did, the little one got an idea, okay? So what he did, he took a mirror, a plain mirror, and then he just landed this plain mirror, or put this plain mirror just at this point. So due to which what's going to happen, the light which was coming initially like this, when it falls or get projected at this point, or you can say it falls at this point of incidence on this plain mirror, it gets reflected. Okay, so this boy got an idea which is like a science of reflection. Got it? So he used it. So now you can see what happens. So they are now explaining us that what happened actually. So there was a light ray which strikes a mirror like this. Okay, and this ray, we know this thing, it is known as incident ray. This ray is what? This ray is incident ray, students. Okay, next thing is this. The point at which it strikes, we know it is what? This point is, students, what? It is point of incidence. Got it? This point is what? This point is what? It is point of incidence. Now what happens? Now see what is happening here. So via this, they're able to make the use of this light. Okay, and they what? They did their works, whatever it was. Okay, if you go in for, I go for fast forward in this video, see what happens.
It's still not working.
My idea is not over yet.
When the
Okay, so what did it actually? Let me show you. They wanted a light to do say some dinner kind of thing. Okay, they actually wanted a light to do some dinner kind of thing. So he put a mirror, one on that side. So maybe they are taking some brunch kind of thing. Okay, so they put a mirror on one side here and a mirror on the other side there, and then they were able to reflect the light at the point where they were sitting or doing or were taking some snacks kind of thing. Got it? So actually they wanted a light because there was night time. Okay, they wanted a light at the region where they were sitting, where they were having the snacks, but they were not able to put the light. So they used two mirrors, one where, one here, and one, it was initially at the down. Okay, so due to the reflection from one first, see, This is the light source. Got it? This is the light source. One mirror he have used here. Let me go back. This is the light source. Okay, so this is the scene. If I zoom, this is the light source. This is the light source. Light is coming like this. One plane mirror is been put here. Okay, it's on the ground, and the light is reflecting like this. You can see this light is reflecting like this. Then one plane mirror is used like this. It's hanging, and light is getting reflected from here to here. And the light is the reflected light where it reaches. The reflected light reaches on this area where this boy want to do the take the refreshments kind of thing. I mean, take some juice, snacks, brunch, whatever. Okay. So this is the picture by the way. If I show you the complete overview, it is like this. See this. Okay. So light source from here, one mirror is here. It gets reflected. It reaches here. Fine. And now he's clapping. Now he's happy. See. So students, this was all about the video. Now it's over. Let me cut this and share the new screen with you. Okay. Is it fine, students? Yes. So we have started. So I hope you understood about the plane mirror, isn't it? Please, anyone of you can text me. So understood that animation, what was going in that? Yes or no? You understood that animation, what was going in that animation? Anyone? That how these two students or these two friends or these two brothers used the knowledge of reflection to handle their work. Okay, I mean, they want the light. They want to solve their purpose. Okay, so what was the purpose? They wanted the light at a region on the mountain when there was complete dark in the sky. So they were having only one source of light, but they were not able to project that light directly on the area where they wanted. What they did, they used two mirrors down and up, and reflection occurred, and the light reached there, and they took snacks. Got it? Yes. So some students are texting me. Yes, yes, yes. Very good, very good. Now, students, let us move to the next slide. This. Yeah, it's already cleared by the way, but for your knowledge, for the theoretical point, if you want to make the notes, it says reflection. What does it say? Is it rain? And normal to the reflecting surface, all light same. This is the first one. What does it mean? It means like this, you know it. Suppose this is a plane mirror. This is a point of incidence. If incident ray is like this, reflected ray is say like this. This is angle of incidence. This is angle of reflection. Okay, and this is G is known as what? This is glancing angle. This is what glancing angle. What's the second point is? Second point is this, and this, the angle with the incident ray mixed with the normal is equals to what? This angle. I equals to what? Angle of these are two laws. It's completed now. Now, students, I'm asking you one question. Then we will end the class. Okay. So I have one question for you, all of you. What are the students in the class? Okay, let me close the video. The question is this. What's the question is? This is plane mirror, students. This is apple. See, if I want, of course, students, if you keep a, suppose this is a plane mirror. If you keep an apple, this suppose this pen is apple. If you keep an apple in front of plane mirror, of course, the image will form inside. Inside means what? Virtual image, not behind. If you're going behind the mirror, suppose this behind it, inside means inside it will be. It's not behind like this. If I go behind here, the image will be no. It's inside in the virtual world, in the mirror world. Okay. So the image will be there. Now, if you practically see that image, how it will look? Will it look like this? Is anyone of you can text me? Is this the right image? Please say, is this image the right image? Students, if this is the object, Apple is the object and this is the image. So I'm asking from you, is this is the right image? Is it right? Yes. So one of the students have texted me. Priyanka says yes. No student is not right image. Okay. It will go muted image. It will not be here. It will be here, like this. This will be the image, and this shining part will be here. This is how you see in the plane mirrors. No student. Got it? What about other students? Nandu and all. What about admin, Ahan Akbar, JNV, IKM, and other students? Rukmani, Sunana, Harshita, and all the students. Okay. So I will say what? This is not a right image, by the way. Image will be how? Image will be like this. Let me show you. And this is how I will draw the image. Okay. I will not draw the precise image, but somehow. Okay, this I've drawn very bad image, by the way. Okay. This I've drawn very bad image. Will be not the complete figure. I hope it's clear, students. Okay. So some of the students have texted me. Let me see it. Cool, cool, cool. Now, if someone asks from you to do the image from the plane mirror, how you will draw, students? The concept is this. Let me tell you the concept. Okay. The concept is this, that suppose you are given a plane mirror like this. Suppose this is, I'm just showing you here a little bit. This is a pen paper. This is a very good image, 3D kind of. But this is what? Simple mirror here. Okay. A pen paper representation of this plane mirror. And if an object O is kept, I'll end the class soon now. Okay. If the object O is kept here. So if they ask from you, find the image. So concept is this, it's object ka, take the perpendicular distance from the plane mirrors, it is D, then just draw a perpendicular line and mark a point in the virtual world that is inside the mirror, or you can see behind in the physics language, at a D distance same, and mark at this point as say I. So this will be the image. Okay. Okay. So if the extended objects are given, how you draw? This is the just point object. Point object के लिए क्या concept है? The concept is this: perpendicular distance of object from plane mirror. Sorry, is the perpendicular distance of image same. Got it? Very good. अगर extended objects दे रखे हो, suppose they are given you say some stick kind of thing, and they have given the plane mirror in front, and they say what is the image. So how will you draw the image? You will draw the image like this. That is, you will take this point. Okay. This point is having say what? D. It is at a D distance here. So we'll draw the image here, D here. And this is what? The second point. It is at D distance here. So we'll draw the image here. Okay. So this will be the image. This will be the image here. Got it? This is the image of the object inside the virtual world. Got it, students? Fine. Harshita says yes. That's good. Okay. Now see the last concept, and I am going to end the class. Relation between velocity of object, velocity of image, and mirror. Okay. So let me explain you this thing. Just hold on. See, just focus here. This is the last concept of our today's class, and then we'll end the class. So it says what? It says like this. See, students, suppose you're having this helicopter, a toy helicopter. It is basically moving towards this plane mirror. Okay. suppose it's given in the question. Here, and take interest in this and stop just with with some speed, which is v object respect. That is r frame. From where I'm sitting here, I'm seeing that this is mirror and the object is moving like this. Okay, and suppose this is mirror and it is also moving with some speed. Mirror is also moving with some speed. Vm with respect to ground. And then we have having each of this, but if you want to find the relation between velocity of object with respect to ground, velocity of mirror with respect to ground, and due to this both, because if the mirror is moving and the object is moving, image inside will also move. Wherever it moves in this direction or in this direction. If you want the connection between these three terms, how will so let me tell you the derivation. Okay, just hold on, students. I'm just telling you a derivation. Let's wait. Okay, see. So suppose we are having here a plane mirror like this. Object here, image here. Okay. So the derivation is this. Okay, I'm giving you the formula. Okay. So we'll say like this. This is Vm speed. This is Vi speed. So the derivation is this one. That is velocity of object constant used to the derivation. Velocity like this, velocity for the question and then end the class. Now I'll solve the question and then we'll end the class. Fine. Or you can take this question as a homework too. Let me show you the question. So we got here. Okay, students. So in the next class, we'll solve it. But remember the formula is velocity. Okay, we'll solve the question in the next class because time is up. We don't have enough time now. It's already 3:57. 3 minutes are remaining. Okay. I just wanted to ask, are you having any doubts? So the conclusion of the class is this. How we can conclude at the end? We can say like this. We understood about the ray optics and what is basically ray optics. Then we understood about this. That is also very good. It was interesting. Laws of reflection, glancing angle, all these things. Then we did what? We have learned how to draw the images after reflection from plane mirror. Then we studied what? When the plane mirror is moving, object is moving. So what's the connection between the formula of the speeds? So these were all things. Okay, no doubt. Good. So students, that was all about today's class. Now I'm ending the class. Bye bye everyone. Take care. Okay, and we'll meet in the next class, whenever it will be. Okay. It will be notified. Okay, and all the students from JNV, Ernakulam, from Nandu, Harshita, bye. Thank you. Okay, everyone. Ahana Akbar, bye. Okay. So I think the time is up. Yeah. If you have question on the top, in the chat box, or you can leave. Bye bye everyone. Okay. So I'm ending the class. Students, I'm ending the class. Okay. Bye, Rukmani and all this, Nandini and all the students. Okay. Bye. So I'm ending this class and